Hello everyone. So today in this video we are going to solve a question of LeetCode, that is valid stack sequences. It is 946 question on LeetCode and it comes under medium category. Alright, so let's start with the problem statement. Given two integer arrays pushed and popped, each with distinct values, return true if this could have been the result of a sequence of push and pop operations on an initially empty stack, or false otherwise. So basically in this question we have given two vectors, like the integer vectors, and we need to check whether the pushed vector and popped vectors are valid or not in case of stack. So we will just try to put all the elements like push element and pop elements into our stack, and we will check whether the stack is empty at the end or not. Alright, so let's quickly understand this with an example. So let me make a multi-line comment here, and let's take the first example. So let me write the push array here. Let's keep I to keep a track of all the elements, then write pop, and let's take j to keep a track. Now let's make a stack here. All right, now the elements in the pushed are 2, like 1, 2, 3, 4 and 5, and in the pop elements are 4, 5, 3, 2 and 1. Like this is the first example. So what we will do, we will just start iterating the pop vector. Once we get the same element as of the pop, so we will just start popping out elements from the stack until the elements are not equal to the pop elements. So let's quickly see. So let's first iterate through the push. So the first element is 1. Let's push it into our stack. Now the second element is 2. Let's push it into our stack since these are not equal to the first element of pop. So let's push 2. Now we have 3. Let's push 3 into our stack. Now we have 4. Let's push 4 into our stack. Now 4 is equal to the jth index of pop. J is initially 0, like the 0th index. So 4 is the 0th index of pop. So let's pop it out from the stack and increment j. Now 3 is not equal to 5. So what we will do, we will just increment, like iterate through the push. So let's push 5 into our stack. Now 5 is equal to the jth index in the pop. So let's pop it out from the stack and increment j. Now 3 is equal to the jth index in the pop. So let's pop it out from the stack and increment j. Now 2 is equal to the jth index. So let's pop out from the stack and increment j. Now 1 is equal to the topmost element on the stack. Now let's remove it and like pop it and increment j. We have iterated through all the elements of the push and stack is empty at the end. It means the operations are correct. Now operations are correct. So what we will do, we will just return true from here. So let's return true from here. This is our first example. Alright, now let's see the second example, that is false. So let me just update something here. Let's stack and let's clear it out. Push array is same 1, 2, 3, 4 and 5. Pop is changed. So let's update the pop here. 4, 3, 5, 1 and 2. Alright, now let's iterate through our push function. It's 1. So let's push 1 into our stack. Now 2. Let's push 2 onto our stack. Now we have 3. Let's push 3 into our stack. Then we have 4. Let's push 4 into our stack. Now 4 is equal to the 0th index of pop. So what we will do, we will just pop out from the stack. Now increment j. 3 is equal to this one. So let's pop out from the stack and increment it. Now these are not equal. So let's see the push function. Let's push 5 into our stack. Now 5 is equal to the jth index. So let's pop out from here and let's increment j. Now 2 is not equal to 1. So let's see push is completed. Like we have completed the iteration of the vector and stack is not empty. So stack is not empty. It means all the operations are not valid. So what we will do, we will just return false from here in this condition. So I hope the examples are clear to you. Let's quickly code the solution. So let me just initialize a stack of integer here. Now let's run a for loop and iterate through our pushed array. Alright, now let's push the element into our stack and let's run a while loop until st dot, like if st not empty, like if it is not empty, and until st dot top is equal to popped j. Let's take an integer variable here which we will be taking the track of popped element. Let's initialize it with 0. Alright, now let's just pop it out the topmost element from the stack and increment j. Alright, at the end just return stack.empty. If the stack is empty at the end, then it will return true, else it will return false. Alright, so let's just run it. Yeah, it's working fine. Now let's just submit it. Yeah, it's working fine. Now let's calculate the time and space complexity of our solution. So time complexity of our solution is big O of n, and space complexity is also big O of n. Since we are storing all the n elements into our stack in the worst condition, and time complexity is big O of n because we are iterating through all the n elements of the vector. Alright, so I hope this approach is clear to you. Now let's see the optimized approach. Like we can optimize the space in some way. So let's see the approach. So what we will do, we will not take a stack here because stack is taking all the n elements. So let's comment it out. And what we will do, we will just update the element into our pushed vector. So let's take another variable int I is equal to 0, and if we are not taking stack, then we will be just updating to our push. So pushed I plus plus will be equal to x, and I should be greater than 0, and here pushed I minus 1 will be equal to popped j. Then let's see I minus minus and j plus plus, and then just check if I is equal to 0. If I is equal to 0, then it means the stack is valid, otherwise it's not. So this approach would work fine, and the space complexity of this approach is big O of 1. We have done a syntax error here. Let me clear. Yeah, it's fine. Now let's just run it. Yeah, it's working fine. So the space complexity of this approach is big O of 1, and time complexity is same, that is big O of n. So I hope you understood both the approaches. If you still have any doubt in this solution, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.